Hello friends, very good morning. In previous lecture, we discussed question related to the order and degree of the differential equation. Now, in this lecture, we proceed them. Now we start solution and initial value problems. A general form for nth order equation with x is independent, y is dependent can be expressed as f xy dy by dx dot dot dny by dxn equal to 0. Say this equation g, where f is a function that depends on x, y and the derivative of y up to the order n. The equation holds for all x on interval I. It means all the solution of the differential equation in the interval this. Now we discuss explicit solution. What is explicit solution? A function, say phi x or yx, we also written as yx, that when substituted for y in equation g satisfy the equation for all x in the interval I is called an explicit solution to the equation on I that is interval a to b. X is lie on a to b. X is the point. When a or b could also be infinite, it means also in minus infinity to infinity. Now we understand this implicit solution by the example. Show that phi x square minus 1 by x is an explicit solution to the linear equation of d square y by dx square minus 2 times y by x square equal to 0. This is the differential equation. But another psi x equal to xq is not an explicit solution of this differential equation. Since we have the differential equation d square y by dx square minus 2 times y by x square equal to 0. Say this is equation 1. And let yx equal to phi x. We let in terms of y. This is for understanding. X square minus x to the power minus 1. This is. Now differentiating yx with respect to x. After differentiating, we get this equation: x square, differentiation of x square is 2x, and differentiation of x to the power minus 1 is equal to minus 1 is here, then minus minus plus, and power minus 1, it means x to the power minus 2. Because this differential equation is highest order is 2, so differentiating again, we get, if we differentiate 2x with respect to x, then we get 2, and differentiating x to the power minus 2, we get minus 2 times, because minus 2 shift here, and x to the power minus 3, because minus 2 minus 1 equal to minus 3, so we get this. Now substitute yx and y double dash x in 1. In 1. 1 is what? d square y by dx square minus 2 times y by x square. After substituting, d square y by dx square is what? Also we can written as new notation y double dash. This means d square y by dx square, and minus 2 times 2 by x square times, here is substituting yx. After calculating this, we get 0, and here is also differential equation, right side is 0. So this is valid for any x not equal to 0. Here is any x not equal to 0 is why? Because 1 by x is not valid for x equal to 0. So we not take 0. Then the function phi x, x square minus 1 by x, is an explicit solution in the interval minus infinity to 0 in open and 0 to infinity. So phi x is an explicit solution in both interval minus infinity to 0 and 0 to infinity. This is the basic concept of understanding the explicit solution of the differential equation. For second equation, sin x equal to xq is not. Now check it again. For let yx equal to sin x equal to xq. Now differentiating with respect to x, we get 3x square, and again differentiating, we get y double dash x equal to 6x. Now substituting yx and y double dash in d square by dx square minus 2 by x square times y. Y double dash is 6x minus 2 by x square into yx is what? Yx is x cube. So put here, and after calculating, we get 4x, which is valid for only for x equal to 0, because second order derivative, this derivative right side is 0. So this is valid for x equal to 0 and not an interval, and not in any interval. So sin x is not a solution or not an explicit solution. Now this is example for you. In same like above, you do show that any choice of the constant C1 and C2. Here C1 and C2 is arbitrary constant, so choose any constant and the function phi x C1 times e to the power minus x plus C2 e to the power 2x is an explicit solution to the differential equation. This proceed same like above and try to show that this is explicit. So now we move to next solution called implicit solution. What is implicit solution? A relation fxy equal to 0 is said to be an implicit solution to the equation G. It means G is what? G is nth differential equation, nth order. On the interval I. If it is defined one or more explicit solution on I, now understand implicit solution by this example. Show that x plus y plus e to the power xy equal to 0 is an implicit solution to the non-linear equation of this. Non-linear is why? Because if we multiply dy by dx, then this function is already, so this is non-linear equation. Now check, since we have the given equation, say it 1 and differentiating 1 with respect to x, because in above differential, differential equation dy by dx, so we differentiate this. If I differentiate with respect to x, x is 1 and y dy by dx plus and e to the power xy becomes by chain rule. With respect, this is y times e to the power xy plus y times e to the power x by y, and differentiating y we get dy by dx, and right side is 0, implies if we arrange dy by dx in same, v becomes this, because dy by dx is common, and plus 1 plus this. This is an implicit solution. Implicit solution is what? Given equation is given and finding the differential equation, and we obtain this differential equation after solution. Now next move to the fundamental concept of general solution, particular solution, and singular solution of the differential equation. General solution, a solution of the differential equation in which number of arbitrary constant is equal to the arbitrary constant c1, c2, dot cn arbitrary constant we take here, to the order of the differential equation is called general solution. We concept this in next particular solution. A solution of the differential equation obtained from general solution by taking some particular value of all arbitrary constant is called particular solution. We understanding this concept by proceeding given suitable examples and understanding this by examples. Now next is singular solution. A solution of the differential equation which is neither a general solution nor particular solution is called singular solution. Now next move to definition related to the above. The function y equal to fx c1 c2 dot dot cn. C1 c2 is what? C1 c2 is an arbitrary constant. Say this equation as a start of the n plus 1 variable. Here is n plus 1 variable. This is n and 1 is x. So total is n plus 1 variables. x1 x c1 comma c2 dot dot cn will be called n parameter family of solution of the nth order differential equation. If xy dy by dx dot dot dny by dxn equal to 0, say as a diamond. This is the notation of diamond in latex. If for each choice of a set of values c1 c2 dot dot cn, the resulting function fx defined by a star, it will now define a function of x alone. Satisfy diamond if f x f dash comma f double dash dot dot fn here we call a solution which contains n arbitrary constant c1 c2 dot dot cn and n parameter family of solution and refer to the constant c1 c2 dot dot cn as a parameters. We call these all arbitrary constants as a parameters. So note 1, the family of a differential equation of order n contains n arbitrary constants c1 c2 dot dot cn. Next, note a differential equation of the nth order has an parameter family of n parameter family of solution. We discuss further in formation of differential equation, rule of forming differential equation, and understanding these all concepts we discuss here. So now proceed formation of differential equations. Working rule to form differential equation from the given equation in x and y containing n arbitrary constant. It means n parameters. Step 1, write the equation of given curve. We discuss in here y equal to fx, c1 c2 cn. Differentiating the equation of a step 1 n times as to get n additional equation containing n arbitrary constant or parameters and derivatives. Eliminating n arbitrary constant from the n plus 1 equations or variables obtained in a step 1 and 2. Thus we obtain the required differential equation. After eliminating the arbitrary constants, we get the required differential equation involving a derivative of nth order. So take a example first. Find the differential equation of the family of curve y equal to e to the power mx, where m is an arbitrary constant. Since here is one arbitrary constant, so we differentiate only one times. Solution: we have y equal to e to the power mx. This is the family of curve. Now because here is one arbitrary constant, we or one parameter, so we differentiating both sides with respect to x, we get dy by dx in left side equal to m times e to the power mx. This implies dy by dx. After differentiating, we get dy by dx equal to ym. Now written as m equal to dy by dx because dividing by this m. And here we also find, if we taking log both side, we find m equal to this. Now putting here m 1 by x log y and right side is dy by y dx. This implies dy by dx equal to 1 by x log y. Now this is the required differential equation of y equal to e to the power mx. This is the required differential equation. So this is exercise for you. Obtain the differential equation, satisfy the family of circle x square plus y square equal to a square, where a being an arbitrary constant. Now second exercise for you, please try to construct a differential equation. Find the differential equation of all circle passes through the origin and whose center are on the x-axis. Now take another example. Find the differential equation whose two parameter family of solution is y equal to c1 times e to the power x plus c2 e to the power minus x. Why does we call this two parameter? Because here is c1 and c2 is the parameter. The question is asked like that. Since we have y equal to c1 e to the power x plus c2 e to the power minus x. Now differentiating with respect to x both sides, dy by dx equal to c1 times e to the power x minus c2 times e to the power minus x. Say this equation 2. Now we differentiating again because here is two parameters, so d square y by dx square equal to c1 times e to the power x plus c2 times e to the power minus x implies this is y equal to, so we put here y and shift on left, we get this. This is the required differential equation of y equal to c1 times e to the power x plus c2 times e to the power minus x. Now we move to initial value problem. So this topic we discuss in next lecture. So we stop here. Please like and subscribe my channel. Thank you very much.